I got it spinning, okay, and you can't tell, but the mark space ratio, it's about, well, you can see it there. So this is the mark, obviously quite noisy, and this is the space between it. And the mark is about, yeah, in the region of 500 microseconds. And there you got your space, 1, 2, 3, 4, 5, 6, 7. So that's 3.5 milliseconds. Yeah. So in other words, it's about 1 to 7 or 1 to 8 or whichever you're calculating it at. These guys are actually okay. They're hot, and I could probably take this down a bit further now. Let's see if I can take it down a bit further. Yeah. There we go. I'm going to take it down. Oh, it stopped. There you go. So we had it running at about 7, didn't we? Yeah. And these guys, they're hot, but they're not burning. If I take it back up to 250, I might be able to get it to re-engage. Yeah, there you go. That's it. You see? There you go. Yeah. 250 to 2000. So that's the mark, 250, and that's the whole period, 2000, to give you an idea, which means that it's 8 to 1, and it's running. Yeah. And these guys are actually running. I'm trying to see if the top ones are getting warm. They are getting a little bit warm, but not much. Yeah, but the bottom ones are getting quite hot. They might cool down a bit now because I'm actually running using an actual PWM rather than it being full mark. So that's actually working now. Yeah. We've still got a problem because these things, and I'm using bare transistors. I've not got any heat sinks on them. But look at that. Yeah. Running much faster now, of course. We're not outputting anything right now, which is the better thing at that moment. But you can see how it's spinning. I don't know what the speed is. We could probably work it out. Because we've got the timings there, haven't we? So we can... Oh, it stopped again. I think these things... Are they getting warm? No, they're actually... I mean, they're still warm, but they're cool... Ooh, that's a bit hot. They're cooling down a bit. Yeah, it's... I'm going to give it a bit of a break. There we go, stop. So now it's stopped the output. But you can see what the output is. Oh! It triggered it, damn it. I didn't want it to. Yeah. So we can do, I can just turn it on just to get a, there we go, stop. Ah! That's it. There we go, stopped it. Right, so we can get an idea, and I can actually, what I can do is I can increase the scale. Right, now we've got it. So the full period, right, this is on 500 microseconds. In fact, it's better if I put it on 1 milli, because it's easier to work, because it's 1 millisecond each then. So we've got approximately 1, so that's the leading edge, 1, 2, 3, 4, right? So the period is 4 milliseconds, right? What does that mean, right? That's 4 milliseconds for the rotor, right, to move from there to there. That will be 4 milliseconds. And we've got 6, right? So that means a full rotation is 24 milliseconds. And I actually don't know how to work that out, but we can give it an idea. Let's see. You'll have to forgive it. I don't know what's going on there. So that's 24 milliseconds divided by 1000 to make it into seconds, right? And then we do 1 over, right? So that's like 41 rotations a second, effectively. It's 41 RP second, and then we'll times that by 60 to get RPM. 2,500 RPM. There you go. So that's actually how much it is. 2,500 RPM it was running at, you know, but based on the frequency. Noisy bugger, I don't know what he's doing. Somebody's making something. Yeah. So it's working. Cool. We're letting these cool down a bit, and then we might give it another go. But these bottom ones are getting hot, and I don't know why. Yeah.